In this video, we will introduce pattern and matcher within the Java programming language. Java.util.regex package offers a powerful and economical object model to implement regular expressions in Java. It is composed entirely of three objects: the pattern object, the matcher object, and a pattern syntax exception. If we look at our code here, the parameter for this method is a string that represents a regular expression. When you pass a string to a method that expects a regular expression, it's important to delimit any characters that the regular expressions might have by appending another backslash character to them. This is because string objects internally use the backslash character to delimit meta characters in character sequences, regardless of whether those character sequences are regular expressions. This is part of using Java. The regular expression \d becomes a string $\d. We saw examples of this in the earlier lessons. Our static method compile string regex returns a pattern object. At times, you can have exceptions when using the regular expression package. An exception can come from the compile method. The compile method will throw a java.util.regex pattern syntax exception if the regular expression itself is badly formed. Let's look at the implementation. You don't catch, or you don't have to catch, a pattern syntax exception every time you use a regular expression, because a pattern syntax exception doesn't have to be explicitly caught. It extends from a runtime exception, and a runtime exception doesn't need to be explicitly caught. There's also an overloaded compile method that looks like this. The string regex and int flags is an overloaded method and more agile method than the just regular compile with the string regex. The first parameter for this method is regex, which is a string that represents a regular expression. The flexibility of this compile method is fully realized by using the second parameter, or int flags. A small example can be if you want it to match regardless of the case of the candidate string. Then your pattern can be like this: regex pattern.caseInsensitive. You can combine the flags by using the plus operator. For example, to achieve Unicode matches that include a comment, you might use the regex expression plus the int flags with the pipe character. Public int flags of the pattern object returns the constant flags that you can use in compiling your regex pattern. The flags method simply returns an integer that represents those flags. If you want to see whether your pattern class is currently using a given flag, we can simply retrieve the flag, such as the code here demonstrates. And then we can do a comparison. And store it in this boolean. Now, to compare your patterns against data or a given string to see if it matches the description you provided, we need to use a pattern.matcher, which returns the matcher that will help get the details about how your string compares with the data you passed in. Pattern.matcher character sequence input takes a character sequence parameter as an input parameter. String implements the character sequence, so you can simply pass a string object as a parameter to the pattern matcher method, as such as the case passing in nap. There are times when you quickly need to know if a string matches a given regular expression, and you don't want to spend the overhead of creating the pattern object, extracting its matcher object, and attempts to find the next subsequence of the input sequence. You can use matches as follows: passing in the regex and the string to search on. This static utility method is designed to internally create the pattern and matcher objects you need. It compares it to the regular expression to the input string and returns a boolean that tells you whether the two match exactly. When you're doing a lot of comparisons, this efficiently and implicitly creates a pattern object and does your matches. Let's run the source code. None were matching here. This concludes our discussion of pattern and matcher in Java.